Section 4.1 is solving systems of linear equations and two variables. There's a few different methods to solve these type of problems, and we're going to cover each of these throughout this lesson. But before we begin, we're going to talk about all the possible solutions that we're going to get. There's this situation which happens most often, and it's where you're going to have one solution, they're consistent and independent, and the answer is an ordered pair. Like, for example, it might be the ordered pair 2, 3. There's this other solution, the second solution. It's where you're going to get parallel lines if you're graphing, or basically these two equations that were given have no points in common, therefore there's no solution. Inconsistent, independent, and sometimes no solution is represented with 0 with a bar through it. And then we have our third possible solution, which is a line and then another line drawn right on top of it, and it's hard to see that. And it says that both of these have infinitely many solutions. That means if they're two of the same lines, they share many, many, many points together. So, and it's represented with this type of answer. So these are our three possible solutions we're going to get to all of the problems that we work. The first method we're going to use is going to be solve by graphing. Now, all solve by graphing, I'm going to tell you to solve each of these for y. Before you begin, we want to solve for y so that we can use slope-intercept form to graph. So if I take my original equation, my first equation, 3y minus 6 equals 0, and I solve this for y, y equals 6, and then we want to divide both sides by 3, and y equals 2. Now, if I want to go ahead and graph that equation, y equals 2 is one of our special cases. It's a horizontal line at 2, but if you didn't memorize that, I could make a table, and this says all my y values need to be 2. Well, then that leaves me to choose any x's I want. I'm just going to pick 0, 1, and 2, some easy ones. If I were to graph this, I would have 0, 2, 1, 2, and then 2, 2, which we notice is going to be a horizontal line at y equals 2. Okay, now we're going to take our second equation, which is this one, and we're going to solve for y as well. To get y by itself, we want to subtract x from both sides. We have 5y equals negative x plus 15. Divide both sides by 5. Everything in the problem by 5. Simplify. Y equals, there's a known 1 in front of that negative, so I'm going to put negative 1/5 x plus 15 divided by 5 is 3. Once we have these simplified, I'm going to ask you to recall the slope, which is negative 1/5, and your y-intercept is the ordered pair 0, 3. Now we remember to graph, we're going to start at our y-intercept, which is this point right here, 0, 3. Right there. And then we're going to rise over run with our slope from that point. So we're at 0, 3, and then we're going to go down 1, right 5. Down 1, right 1, 2, 3, 4, down 1, right 5. And that's where we're going to put our mark. And I'm going to do the best I can to get a straight line through there. Let's see. About right there. Now, the way we state the solution to this is we look and we see, do they cross or touch? Are they parallel, or are they right on top of each other? If we look back, we see that it's this situation. It's the first possible situation, and we need to name that point. So I want to name the point which they cross, which it looks like the ordered pair 5, 2. So our answer to this is going to be the ordered pair 5, 2. Okay? Likewise, since this is still graphing, I'm going to ask you to solve for y. Okay, we're going to take the first equation, 4x minus y equals 4 and solve for y. Don't forget to bring down that negative. Divide everything by -1. And we have y equals 4x minus 4. My slope of this one is going to be 4, and my y-intercept is 0, -4. So I'm going to take a minute and graph it. 0, -4 is here, put a dot, and then I'm going to rise over run. So up 4, right 1. So from 0, -4, I'm going to go up 4, right 1, which is right here. I'm going to get a line and draw a line through it. Now we're going to take equation 2, which is our second equation, and repeat the process. Solve for y. Move 8x to the other side. Bring down -2y. Divide everything by a -2 and then simplify. Y equals 4x minus 2. We're going to name our slope, and our y-intercept is going to be 0, -2. So when I plot this one, I start at 0, -2, which is here, and then I'm going to rise over run, so I'm going to go up 4, right 1, which is right here. Graph that. And you notice that these are parallel lines. Parallel lines, they never cross, they never touch. Their answer is this, which also means no solution. And they're inconsistent. Now, to tie in the information, we also said when we looked at these two, we see that they both have the same slope, and we knew that parallel means they have same slope. So you kind of have an idea of what the answer is going to be before you ever even actually graph that one.